Hey everybody, it's our first video of 2021. So we're going to start off this year with Unit 5. And in this first section of notes, we're going to focus on the Earth's geology, earthquakes, and volcanoes. So let's go ahead and turn to page 54 in your notes. All right. So you guys have all seen about earthquakes and volcanoes, but now you're really going to understand the processes that cause them to happen and why our continents are constantly shifting. All right. So if you think back to elementary school, you guys learned about the layers of the earth. Well, those layers are still the same, but we're going to add in a couple of different sections that also contribute to the movement of things. So we know that, if you look at this picture right here, okay, you know that there are three basic layers, okay? You have the core, the mantle, and the crust. We're going to add in a couple more to that. So let's go ahead and start with the core. So we have the core. The core is the innermost layer, as you guys probably remember. It's like I'm going to have to practice my handwriting again. I'm a little bit out of practice. So it is the innermost layer, and it is made of nickel and iron. All right? And keep in mind that it is a solid. All right? So from the core, we then have the mantle. And you guys don't have to know about inner core, outer core, and all that. You just need to know the core. So the mantle we see is the middle section. Now the mantle is where we have basically the movement of the magma, okay? It contains magma. And I'm going to show you guys a picture that's going to illustrate how the magma moves inside the earth. And it's going to be those convection currents that we learned about last semester. So we have the core, we have the mantle, and we have the top layer, which is the crust. Okay, so the crust is obviously the outermost layer. All right, now there's a couple specific layers that we're going to throw into this that you guys need to know about. So the first one, if you look at this picture right here, okay, we see what's called the lithosphere and the asthenosphere. Okay, so the lithosphere, if you look at the picture, what does it look like it is? It is the very top layer of crust. So this is where we see the actual direct impact of earthquakes and volcanoes. This is where we see the cracks. This is where we see the magma flowing through. Okay, so the lithosphere is the top layer of crust. Now we have the asthenosphere. The asthenosphere is the upper layer of mantle. I know it looks like it's part of the crust, but it's actually not. It is the upper layer of mantle. Okay? And it is what we call semi-molten. It's not completely molten like the mantle. It's not completely liquid. It's semi-molten, meaning that it's very hot, and then when you have rocks in that layer, they can melt. So it is kind of in between a state of liquid and solid. All right, so those are the layers of the earth. All right, so let's look at the layers of the earth in comparison to the United States. A lot of people don't really understand how deep the earth actually goes, and I think this is a really good visual for that. So here we have the crust, and here is the inner core. So basically you can see that if you were to drill straight down to the core, which right now is impossible for us, it is roughly the width of the United States. Okay. So from the crust all the way to the inner core is roughly the width of the United States, which is about 3,300 miles deep. Or, we say, because it's a science, 5,400 kilometers. Okay? All right. Now, this picture shows us exactly how the mantle works. Okay? So, here we have the top layer. So this is our crust or the lithosphere. Okay? Here's that asthenosphere. This is that semi-molten layer, remember? Okay? And here is the mantle. So here's this term convection. Now, we learned about convection during our weather unit when we were looking at how air flows. Magma does the exact same thing. So we know that heat rises. So you can see it's a circulation. So when magma gets heated, it rises up. Okay? When it rises up, it cools down. It's losing energy, and so it drops. And it goes back down toward the middle of the earth where it picks up more heat and rises. So this is a continuous cycle. Okay? So when we look at this, we say that the heat from the core causes the magma to well upwards. Okay? So heat from the core allows magma to well upwards. Okay? So it picks up heat towards the core and rises up towards the surface. All right, so as the magma rises, it cools off because it's losing energy. So as magma rises towards the crust, as magma rises, it cools down. And sinks to the bottom. So it goes back towards the core, okay? So I really want you guys to understand how the energy works in this. So when something cools down, it's losing energy, so it sinks. When something warms up, it gains energy, so it rises, okay? Now, right here, a spreading zone. So this is going to be where two plates meet, and we're going to talk about that in just a second. So this right here, potentially, we could see a volcano or an earthquake right here. Okay, so where we see magma actually reach the surface of the crust, the surface of the planet, that's going to be a volcano. Okay, so that is what this is showing you right here. Okay, so let's look into a little bit more of the geological history of what this is causing. Okay, now you may or may not know, I'm assuming that most of you do, that the continents were once connected into a supercontinent. And in your head, you're probably saying, yes, miss, it's Pangaea or Pangea. Doesn't matter how you say it. This is true. So the continents were once connected in a supercontinent. So the continents were once connected into a, no, I cannot write today, into a supercontinent. And that is Pangaea. Okay. Now, this also explains why we can see certain fossils of the same type of animal in different locations in the earth. So if you look right here, okay, Mesosaurus, you can see fossils of Mesosaurus in South Africa and in Africa. Okay, right now, that's two different sides of the planet, but they were closely connected when Pangaea was around. Okay, so when we look at these continents, we know that they sit on what we call plates. Okay, so each continent sits on its own plate. The Earth's lithosphere, remember the top layer of crust, the Earth's lithosphere is divided into plates. Okay? The plates are always moving. They're shifting. That's why Pangaea is not Pangaea anymore. That's why we don't have one supercontinent anymore. It's because these plates are constantly moving. They're shifting apart. Okay? So the plates move due to what we call tectonic motion. Oh, where'd my mouse go? Is it over there? Here we go. Due to tectonic motion. Okay, so tectonic motion is the actual motion of the plates. And so this causes continents to drift apart. Okay, so if we go back up here, each one of these is a tectonic plate. Okay, that's how that works. So the continents sit on plates. Tectonic plates, they're constantly moving. So this right here, this picture is showing us the names of the plates and how they border each other. So different colors indicate a different plate. So this map shows you the name of the plate. So we have the North American plate, where we are, okay? You've got the South American plate, the African plate, multiple different plates, and they all border each other. So that means that they're going to interact with each other. So tectonic plates border each other and create boundaries. Okay, so these boundaries is where we're going to see all of that geologic activity. So most tectonic plate action will be at the boundaries of the plates. So this is where we're going to see earthquakes and volcanoes. Okay, at those borders is where we see most of the activity. Okay, so this picture, that's what it is showing you. You can see that the map is showing you the plate boundaries, and where you see a triangle or a dot, that is an earthquake or a volcano. So you can see by looking at the map that most geologic activity occurs at the boundaries. Okay? So the majority occurs at the boundaries. Okay? So remember, triangle equals volcano. The dot is an earthquake. All right. We will finish up the next page on the next video.